Hello everyone! Welcome back to the sequence of videos when we are going to be learning how to find maximum and minimums of the given functions either from the graph or from the equation, the expression of the function which is given. Today we're going to learn how to proceed with a situation when you are given a function on the closed interval. This has a completely different idea. Since in the previous video, now we know that if the function is continuous and it is given on the closed interval from a to b, it is guaranteed to have an absolute minimum or absolute maximum. That was given in the extreme value theorem we covered last time. And it makes sense because the function doesn't make any jumps, any gaps, and since ends are included somewhere between a and b, there will be the highest point and there will be the deepest point, the lowest point as well. So it completely makes sense. So let me give you some nice steps how to find the absolute minimum and maximum of the functions like below on the given interval. Step 1. First, find critical numbers. What are those critical numbers? We just gave you a definition. This is where your derivative is 0 or d and e. Does not exist. From now on, if you see this phrase, find critical numbers, that's it. That's what you do. You differentiate. Set your derivative to be 0 and find where it is also does not exist. Then, the thing is, you might have extra points. Here's the example on the graph. For example, this point over here, this point is global maximum. You see, it's the highest one, much higher than the one I had before in pink. Or maybe over here, it's the global minimum over here. But if I'm still working on the interval a and b, the situation should be considered only from a to b. These points should be crossed away from the list, even though they will show up from the equation. You will see that. So your job is to make sure you cross off the extra points you will have, which means you should not include critical numbers outside of the domain. Just check which points are not in the domain. These will be extras, we don't need them. Then list all the, so that's my step 1a and 1b. Find all possible points and then just make sure you don't include extras. 2a and 2b is creating a list. Create a list of all critical numbers you just found plus endpoints. My endpoints are a and b, right? So you can even write down x equals a, or maybe it's t or whatever variable you have, x equals b. Those will be candidates for absolute maxima and minima, just candidates. We still need to check which one will give you the biggest output and which one will give you the smallest output. When you have this list, your last step is to evaluate function f at those critical points and the endpoints. Because potentially, look at my graph, the absolute maximum might happen both in the middle or maybe it jumps up at the endpoint. So we have to take into account all those situations. And you will have examples when you had both situations. When you calculated all the outputs for all critical values and all endpoints, choose the largest and the smallest. The largest, guess what, will give you absolute maximum, and the smallest will give you the absolute minimum, respectively. So let's proceed to do that on the example over here. Example number 1, I will do a, let's do 1. Find the absolute maximum and minimum points of. I changed the values to points because points means we will require you to find both x and y. That makes sense. If I am, for example, having a business on, say, Amazon, and this is the graph of me selling some items, I want to know not only when did my profit hit the maximum, but also what was that profit. So say at day 3, or it was January 3, the profit was $5,000. And then the minimum over here at March 15, the profit was only $10. And this is the pair. That's why it's important for us to know the pair. 3,5,000 gives more information than just 3. So I want to know both input and output. Okay, here's the function. F of x equals x to the 2/3 times 2 minus x on the given interval -1 and 2. If you see this type of the question when the interval is given and the function is continuous, then it means we wanted to find local absolute extreme values. To use those steps you see right now, we just listed them all. But you know, this function is just so weird. I don't know what it means, so I just graphed it. I used some tool I have and I made a graph for you guys. Maybe we can just detect it from the graph and then we don't have to be bothered. Okay, the graph doesn't look very straightforward either. Where is the biggest point and where is the smallest point? I see some local maximum, local minimums. This is my local minimum. And somewhere over here, I don't know where, maybe over here, is local maximum. Also, this graph is too big. I should cut it over here at -1. And I should cut it at 2 over here, including endpoints. So my actual graph will look like this, pink color. From here, going up and down. We ask you to identify all tips of the mountains and bottoms of the pits, and then check what's happening at the endpoints, and then tell us which input gives you the highest output and which input gives you the smallest output. From this graph, maybe you already have some intuition of what's going on. Let's proceed to calculations. Calculations here, step 1. They want me to find absolute minimum maximum. Step 1 is to find critical values, critical numbers. Let's do CN. The critical numbers are the derivative of the function and where it is 0 or D and E. So first, let me find a derivative. But I don't want to do product rule. If you want to do product rule, do it right now and compare with my answer. I will first distribute everything, and I will have 2x to the 2/3 minus x, and I will have 2/3 plus 3/3, that's 5/3. Now you can find a derivative. Find derivative. Do you want to do it yourself? Maybe pause first and then continue. I'm having 4/3 x, 2/3 minus 3/3 is -1/3 minus 5/3 x. 5/3 minus 3/3 is 2/3. And I will put this into my box. It's going to be a very good habit in the future to put your first, second derivatives into the box, because later on we will ask you to use this information in the future. So now what do we need to do here? This is my derivative if I want to find where it is 0 and where it is D and E. Okay, I will write this down. I want to know where it is 0 and where it is D and E. It does not exist. Yeah, doesn't look nice. And here is a recommendation I always give to students. If you have several parts of x in your derivative and we ask you to find zeros in D and E's, create a common fraction. That's a very good recommendation. Create one common fraction. In this case, basically we want you to create a common denominator. Make sense? So, how to create a common denominator from this piece? Choose x with the smallest exponent. Since one exponent is negative, I will choose that one to be in the denominator. -1/3 gives me 1/3 in the denominator. So that's going to be my common denominator for x. Then do you see any common number we can have in the denominator? I see 3. So 3x to the 1/3 is my common denominator. Then this is my notation. Since the first term already has 4 over 3x to the 1/3, I don't multiply by anything over there, and the top, this part will be just 4 minus. But for the second part, I actually have to multiply by, I'm gonna multiply by x to the 1/3 and see what's going to happen. It will be 5, because 3 already went to the common denominator, and then x 2/3 plus 1/3 is going to be x to the 3/3. That's just x. So that's my derivative. And I'll put this one in the box. Okay, nice. I just need to find out where this derivative is 0 in D and E. Zeros are coming from the top part. D and E are coming from the bottom part. Make sense? So 4 minus 5x should be 0. And 3x 1 to the 1/3 should be 0. All of these cases will give me critical numbers. Let's see what's going to happen. When numerator is 0, the whole fraction is 0. So those are numbers where derivative is 0. And in this case, this is x equals 4/5. Now that's my critical number. Put it in the box, we will need it. Critical number. Do you know why I don't call it critical point? Because I never found output for that x. If you find the output, you will have critical point. We will do it later. For the second part, x equals 0 is the answer, right? Because when else 3 times x raised to the 1/3 is 0. When x is 0. That's my second critical number. But this critical number came from the making my derivative d and e, for making the denominator 0. So we are done with the step 1a. That was 1a. 1a, if you remember, says find all possible derivatives, find the derivative and then find all possible critical numbers from the derivative. Here they are. Now, I want you to check the step 1b. 1b says, you know what, make sure you don't have extras. So I need to check the domain. And domain is coming from that interval we have, -1 and 2. And also maybe your original function is restricted in a domain. Maybe some x cannot be 0 or something like that. So make sure you don't have points outside of the domain. Well, both x equals 4/5 and x equals 0 are in the domain. It makes sense because they are both inside of that interval, and the interval from -1 to 2 is fine. 4/5 is not greater than 2. Nice, so we don't have to cross out anything. Step 2, list critical numbers in the domain -1 and 2, right? And, well, actually, that's, I guess, extra note. We don't have to do that because we already crossed everything out. And endpoints. And I do 2a and 2b in one place. I like making tables. So the table will look like this. X equals 4/5. I'm making literally a list. X equals 0. Then x equals -1. Then x equals 2. Did you catch where I got those numbers, -1 and 2? No? Then I will just write down, this is my A and this is my B. They're coming from here. Look at this interval. Those are my A and my B endpoints. Now all of these are potential to be global maximum, global minimums. Maybe even all of them are minimums. Why not? Maybe the function is going up and down and up and down, just like sine and cosine, and always hits the same maximum, same minimum. That's possible. Now, I don't remember the original function, so I would like to write it down over here to make sure I'm plugging everything in the right place. And that's where many students get confused. You need to plug everything into original function. The original function is x to the 2/3 2 minus x. Now I'll keep it in the original form. You'll see why. For example, when I plug 2, f of 2 is 0. Yes, because 2 minus 2 gives you 0 in parentheses. That's a good one. Also here, f of 0 is, since there's a 0 since there's an x in front of the 2 minus x, it makes everything 0. So at least 2 points are given fast. Then f at -1 is pretty easy to calculate. -1 to 2/3. 2/3, if you don't remember, means squared and then cube root. And then 2 minus -1. If you carefully calculate everything, the first piece is just 1, the second piece is 3. So that's 3. And f of 4/5, the same idea. So calculate by yourself, and I will give you the approximate answer, 1.03. So we have outputs for each inputs. Inputs are critical number, A and B. Those are endpoints. I can even write down if you want. Endpoints. And this is always how we expect you to do it. In this list, I think it's very nice. Last, step 3, if you check. Step 3 tells you find the biggest number in the output and the smallest number in the output. Those are maximum minimums. What do you see? The smallest number. I see 2. So there are 2 global minimums. 0 and 0 are the smallest output. That's going to be global minimum, and this is going to be global minimum. Then do you see global maximum? What's the biggest output? Yes, exactly, 3. So that's going to be global maximum. And the other point, 1.03, is not really anything important, so we don't have to include that. So the answer will be answer. Remember we asked you to find points? Well, now we have those points. Points basically are points. The extreme points, I would even write down extreme points. Extreme points are x, y, where your function hits global maximum, global minimum. So usually the answer should look like this, nicely written. I'll write down global maximum. It doesn't matter which one you write first, unless your online homework tells you which one should go first. Global maximum is happening at -1, and it is 3. Make sense? So at x equals -1, y is 3. And this 3 is global maximum. And we have 2 global minimums. First global minimum happens at 0, and the output is 0. And the second one is shifted to 2. So x is 2. And what is the output? It makes sense that it's the same 0, because that should be the case since this is global minimum. And here is the picture I prepared for you, which explains everything really well. We saw this graph before, and now it shows you that indeed this left endpoint is very high. So it became absolute maximum, -1 and 3. Since 3 is the highest level of this function on the given interval, that's global maximum. This over here is local maximum. It was not the biggest one, even though we found it. 4/5, 1.03 is local maximum. Do you understand that it might be global maximum if I cut, say, over here? If I cut at -0.3, yeah? If I cut over here, then this left endpoint will be smaller. Let me even cut smaller, -0.1, very close to 0, over here. If I make a cut, my interval will be from -0.1 to 2, then this local minimum we found becomes global, not local maximum. This local maximum we found becomes global maximum, because now it's higher than left and right endpoint. That's the interesting idea, because I might ask you the question, what was the highest profit of my business, but not from January anymore like I asked before. Let's check only from February 14 to whatever I want. The moment I switch to different interval, make a different cut, or expand the interval, I have more or less points to look at, and the situation might change. Now, what about global minimums? We have 2 of them. Twice the function hits 0 at 0 and 2 on the given interval. So those are 2 absolute and local as well minimums. Do you understand that absolute extrema is local extrema as well? All extreme values are locals, but some of them are absolute. So we can say that this absolute one is actually local, but not local is actually absolute. Think about it for a second. Let's do one more example, but if you think you're already good at everything, then I encourage you to go and do your homework. But I do have one more example here where we're gonna walk through the idea what to do when we have extra points. And this example is a little bit easier. Example number 2. Find extreme values for f of x equals x cubed minus 3x squared plus 1 on negative 1/2. And then I actually change it later to 1. So let's do 1 and 4. Here's the graph of the function. Look at this. Very nice. And actually it's plotted from... It's not plotted from 1 and 4, but I can definitely check out how it's gonna look like from 1 and 4. This is a cubic function, and from 1 to 4, it's going to be over here and say over here. Then only this piece is actually under the question. Now I want to find out where is my global minimum, global maximum happening on this interval for this function. Let's do it. Step 1. Now let's see how fast you can do it. Maybe pause, do it yourself and see if your answer matches with my answer. So first step is derivative. Let's do the derivative really fast. It's going to be 3x squared minus 6x. Nice. And now I want to make it 0 and d and e, right? But since it's a quadratic function, d and e at no points. So it means it's always, it doesn't have any d and e roots. It always continues and there is no asymptotes and so on. So we just need to solve it for 0. Well, to solve an equation like this for 0, I will recommend you to factor out 3x. Then it's going to be x minus 2 equals 0. Then I have two roots, x equals 0 and x equals 2, and those are critical numbers. Now check if those critical numbers are in the domain. That's going to be 1a, 1b. 1b, the domain is, so the cubic function exists everywhere, but it was cut from 1 to 4. 1 to 4, right? Wow, so x equals 0 is actually, should be kicked out. You know how we got it? It's over here on the graph. This one was extra. The function told you about that situation, that there is some kind of local maximum happening, but since I cut off the function at 1, we don't need to look at 0. So step 2 is almost there, almost the answer. List. Make a list. X equals 1. That's my A. B. X equals 4. And the critical value only x equals 2. That's my list. A function. I don't remember the function and I like to rewriting it again, but you don't have to. F of x is x cubed minus 3x squared plus 1. Then f at, well, let me lift it a little bit. Then f at 1 is 1 minus 3 plus 1, which is 2 minus 3, which is negative 1. Nice. F at 4 is, calculate carefully, it's going to be 4 cubed minus 3 times 4 squared plus 1. Am I faster than you are? 17. Okay, the 17 part, I just checked my notes. I should tell you I'm not a genius to know calculation so fast. F of 2 is 2 cubed minus 3 times 2 squared plus 1. And that one is negative 3. Last step is the best one, because you just need to choose the winners. The biggest value is 17, so that one gives you global max. Global max found. The smallest value is negative 3, so that one gives you global mean. Enter. Answer. always answer the pairs because it's just more information, unless we just tell you to answer the input X. So global maximum happens at, where did it happen? At 4. How do I know? Here it is. 4,17. Global minimum happens at 2 and -3. So wait, does it mean that the graph was right? Look at the graph. The graph told me that this point on the right definitely will be the highest one. So that's going to be global maximum over here. We could see it now at 4. Then this point is not the smallest one because this pit seems to be smaller than this edge. And it happens at 2. Global minimum. So having a graph in front of you is actually very helpful because you can A, check yourself that you did not mess up, and B, make sure that your answers, make sense. If you get something like -million, I don't even see it on the graph. So it's very convenient and a good idea to always use your graphing calculator or any graphing tool you have to check the answer. Okay, hopefully you got it and it was not too fast at the end. Practice more, you'll be very fluent in those topics, and I'm pretty sure you will enjoy it at some point because it's pretty straightforward. Just don't mess up with calculations, read carefully, do we need to have a pair of numbers or just input, and always try to interpret in your head what is going on. Global minimum is the input that gives you the smallest output. Global maximum is the input that gives you the biggest output. That's the idea. Thank you for watching.